Good morning, everyone. Thank you for joining us in the room here. And thanks all the panelists for joining from different parts of the world. And welcome to the second panel discussion. And today's topic is Wi-Fi 6 versus 5G. And a point of this discussion is to see whether these two technologies will complement each other or will one oust the other. So for example, in a campus like this, in this hotel, will there be Wi-Fi boxes at all, or will each of these endpoints just connect with 5G, with slicing and everything will just work fine? So to discuss this and much more is a very eminent panel moderated by Professor Dinesh Bharadia from UCSD EC department. It's my pleasure to introduce to you Professor Dinesh. He did his
Hi.
bachelor's degree in electrical engineering from IIT Kanpur, where he received the gold medal for graduating top of his class. He received his PhD from Stanford and was a postdoctoral associate at MIT. He built a prototype of a radio that invalidated a long-held assumption in wireless that radios cannot transmit and receive at the same time on the same frequency. For this, he was named to Forbes 30 Under 30 for the science category worldwide list. He was named as one of the top 35 innovators under 35 in the world by MIT Technology Review. His research interests include advancing the theory and design of modern wireless communication systems, wireless imaging, sensor networks, and data center networks. Over to you, Professor Dinesh, for this exciting panel discussion. Thank you.
Thank you, Lakshmi. Thank you for the warm introduction and probably slightly, yeah. Any case, great introduction. So moving on, right? I think I will try to introduce all our panelists, right? And I'll be brief, right? So Subodh joins from Cisco, and he has worked from 3G to 5G all the way, right? And have been working on security, SDN, IoT, virtualization, automation, right? Cloud and ML frameworks, right? He implemented secure solutions for mass scale architecture for clients, right? To name a few, AT&T, T-Mobile, Verizon, Rakuten, Geo, and many more tier one companies as well: Walmart, Amazon, JPMC, Citibank, right? HSBC. Um, so I'm gonna let Subodh add to more as in when he speaks up, right? I next introduce Dr. Ashutosh Datta. I presume everybody is doctor, but I just maybe the ones I know are doctors. I will just refer as doctors. Uh, but Ashutosh Datta is currently, or sorry, is at John Hopkins, right? But previously he was at AT&T's security office and chief security office, and he led a group which was responsible for the design and architecture of security for next-generation mobility networks. So there is a very warm panel on security and privacy, really, which is exciting because wireless really requires these days. His more than 25 years of career includes CTO of wireless at a cybersecurity company in Nixon, senior scientist at Telecordia Research, director of Central Research Facility at Columbia University, and computer engineering with Tata Motors. And um, he has more than 80 conference and journal publication, 4 book chapters, 30 issued patents, and has given tutorials at various conferences and online. Welcome, Ashutosh.
Thank you.
Next, we have Sanyogita Shamsunder. She's VP of Technology Development at and 5G Labs with Verizon. Sanyogita is revolutionizing the new ways technologies are being developed and deployed across the business and customer sector. Her team is responsible for new technology platforms such as augmented reality, computer vision, location, and quantum technologies. Right. Sayongita's work experience span all areas of wireless business, including silicon network. Uh, Sorry, just give me 1 second. I have my screen froze. Okay, yeah, I think silicon network technology development, marketing, planning, and strategy for both enterprise and small businesses, which is extremely relevant to what we are going to discuss today. And welcome, Sanyogita. Appreciate you taking this late night panel with us.
Thank you.
Next, we have Hemant Kumar Rath. So Hemant is a senior IEEE member and works as principal scientist in TCS Research and Innovation. Right, he has more than 20 years of experience in academics, research and innovation, standardization and product development. Hemant holds MTech and PhD from IIT Bombay and B from UC Burla Sambhalpur. And he has published many research papers into national and international avenues, right? And thank you, Hemant. I think we would very
Thank you.
much appreciate your end-to-end experience in Indian sub domain, and I think probably only one who has extensively been in India amongst all the panelists.
Thank you.
Um, thank you, Hemant. So finally, we have two more. I think they get a slightly larger banner because I couldn't fit all of six people in one slide. Give me 1 second. Again, my screen is froze. All right. So we have Dorothy Stanley from HP. So give me 1 second again. So Dorothy Stanley is an HP fellow and head of standard strategy at Aruba, HP enterprise company. She currently serves as chair of 802.11 working group IEEE. She chaired several task groups in 802.11 working group and has also served in numerous leadership roles in Wi-Fi Alliance. So that gives us a very good coverage on Wi-Fi side as well. Welcome, Dorothy, and we appreciate you joining this panel. And
Thank you. Happy to be here.
fantastic. And finally, we have Victor Bal. Victor Bal, I think probably a lot of us know him, right? I think, but I'll still do the needful introduction, right? So Victor recently has moved as a new role into Azure as CTO of AFO. Maybe I don't know these acronyms. Maybe Victor can correct me there. But basically, he's moved into a role where he's trying to bring 5G to the rest of the via RAN intelligent controllers and other aspects in a big scale with Azure to a lot of us, right? And this is where I think I see a great panelist, right, who has been on the 5G private 5G end as well, and also been on the Wi-Fi end, right? So Victor's very early work has been into Wi-Fi and edge compute, right? And recently he has been moving into more 5G and been trying to drive that within the CTO office of Microsoft. Victor, welcome. Thank you for joining us.
Thank you very much. Great to be here.
Sounds good. So let me set, I'll speak for 1 or 2 minutes and then I'll start moderating, right? So here's what I'm hoping we would achieve, right, with this panel. And I'm setting a high bar and agenda, right? And hope we can give something useful for all of you listening out there. So basically, one, I want to understand and see what are the research topics and areas which are unexplored, both Wi-Fi 6 and private 5G, and how that would help them compete better with each other, right? Okay. Innovation is bred by competition, right, in some sense, right, and therefore there is necessity that these two compete with each other nicely and also complement to some extent, right. Next, also think about not only this, this is not just a venue where academics, but it also a lot of industry folks are here. So if somebody wants to do a startup or a company that has a business area and ideas which I think we can give them, we should do them, right. Again, as I said, innovation is bred by competition, so we need more people doing things on this space, right. Finally, I would ask panelists to also give us some venues on how you can conduct research slash commercialization activities on both private 5G space, and there is a lot of activity in ORAN, and they can comment on this, right, or RAN intelligent controller, right. A lot of modes are becoming enabling or are made enabled by the by this new activities, right, even in the cellular space, right, which has been a very close corded space, now has been becoming more open, right. So this really makes exciting times to be doing wireless is such, right. Finally, I think there has been a lot of platforms out there in Wi-Fi 6 as well, but I think our panelists can throw a better light on which avenues are more effective against for research and commercialization, right. And then I hope some of you would take up some of these ideas this panel generates, right, and or topics, right, and work on them next. All right, with that, let's get started. I think I took already 10 minutes. I was hoping to be short and crisp, right? So I'm going to give one slide rough how traditionally things has been. So I think Wi-Fi and private 5G, I might use P5G or 5G. Please note that these are all just 5G variations, right? Both are simultaneously complementary, competitive and are converging. Okay, so why are they complementary? Because really, if you think about today's outdoor deployments, right, are most focused on just the 5G or cellular, right? Okay, because they support nicely wide areas, a lot of users, and mobility really well, right? In contrast, Wi-Fi has been more suitable for indoor and small outdoor areas, right? Especially for high density bulk data and providing ubiquitous device support, right? So this is really where they have been, right? And there are a lot of gaps from this campus setting, right? Let's put it where Wi-Fi is more deployed often, right? To more, let's say, this outdoor type settings, right? There are like these different avenues opening up, applications opening up, which has different requirements, and both these technologies are competing with each other to try to fill in that gap, right? That's where they become very competitive, and which is good, because then as a user on the other side can also have a choice to see which solution to adopt for them, right? uh, and we'll discuss on many other aspects how they're competitive and complementary, right? But now the other thing is that really, if you think about it, right, the world is converging towards really providing high throughput, low latency, and high capacity. By capacity I mean a lot of scaling to a lot of users, right? Okay, and both have the same foundational principles, right, where they are trying to scale up to, right? Okay. um, let's start with I'm just putting this Wi-Fi controller diagram. It's by no means the latest and the greatest, right? Just to give you a picture of how Wi-Fi is deployed typically today, right? And what I want to go ahead and start with one bullet point at a time and ask panelists to comment on it, right? And share their opinions and thoughts on it. I have put down many of these topics. Some may not apply to Wi-Fi, right? And I might be incorrect on that, right? So I'm gonna start with maybe throughput on the Wi-Fi, and like what I would request panelists to give trends and where it's lacking and where it can improve in Wi-Fi 6 as such, right? So Dorothy, if you don't mind, may I ask you to start and hit the floor running?
So I'd be happy to. And I think if we're going to go through each of these topics, we'll be here for quite a long time. I think so. Certainly, Wi-Fi throughput. The trend that we've been following in development of the standards from 11N to 11AC, 11AX, known as Wi-Fi 6 and Wi-Fi 6E, and then continuing on with new amendments under development with 802.11 BE, is to increase the throughput capabilities, and often by significant amounts. Recall that 11N was the first technology where you could really talk about wireline replacements. And we've seen enterprise applications go from wired, totally wired Ethernet deployments, to a combination of Ethernet and wireless in some areas, to now where you have some offices and enterprise deployments that are completely wireless. So the trend here will continue to improve both the throughput, latency, user scalability, etc. I'll note that 11BE is targeting configurations that can support 30 to 40 gigabits per second throughput. One other comment is going back to the title of the talk and the future really of enterprise networking. It's important to note that enterprises today really are multi-RAN uh, um, deployments. You have not only Wi-Fi, you have often Bluetooth for ranging applications. You have Zigbee and its variations for IoT applications. And so really enterprises are looking for technologies that meet the needs that they have. And so to the extent that private 5G offers a solution for certain use cases, that's very possible to see deployed. Over to you. You're on mute, Dinesh.
Dinesh, we cannot hear you if you are speaking.
He's frozen.
Oh,
He was having trouble with his computer. So maybe.
Hello.
Maybe.
Hello.
Yeah.
He's still muted.
Until he speaks, maybe we can discuss this a little bit more.
Okay.
Dorothy, I know until he comes back. I was thinking.
Go ahead. Go ahead. Can you hear me?
Yeah. Okay. Good. Yeah.
Finally. Okay. Yeah, I think please continue. Please continue. Ashutosh or was it Hemant? I didn't hear there. Who?
No, this is Ashutosh. I was just telling since until you were back, I was
Yes.
kind
Please
of
go ahead. Please go ahead.
started to do some brainstorming with Dorothy on this in terms of frequency side, right? You have the throughput and which specific frequency you'll be using and the correlation with that. Is that something we should be discussing at all?
Yes, for
well,
sure. I think so. Good. Yeah. Good, Dorothy. Yeah.
okay, right. So generally the throughput is highest in 5 and 6 gigahertz bands, and it's really a function of the amount of spectrum that's available. So whether you have a small number of 20 megahertz channels, or you can provide 40, 80, 160, and with 11BE and Wi-Fi 6E, which is 6 gigahertz spectrum, which is becoming available in more and more countries via regulatory action, that you can really have very high throughput operation.
Sounds good.
Over.
So I think I will ask maybe Sanyogita and others to comment more and to ask pinpointed questions. So I have some questions, right? In terms of throughput, probably it's attaining like the 10 gigabits in what you're saying, right? But there are a lot of latency related issues, right? For example, if you go to smart manufacturing, right, people are still not looking for Wi-Fi as such, right? And before you answer to that question, I want rather Sanyogita to add to this input more on this point, right? And see if she can ask more pinpointed questions on throughput and latency as well for Wi-Fi 6 as such.
Yeah, thanks. I think Dorothy made a good overall point, right? I think we can. I'm not sure we want to be talking about one thing. I mean, I think there are multiple different use cases warrant the use of different networks. I think, and it's almost a given now that you have all kinds. And if you want to just focus on maybe the high bandwidth, high throughput networks, which is either 5G, 4G, or Wi-Fi 6. I think it's probably nitpicking at this time when we say throughput and so on. I think they're all kind of competing. And I would say Wi-Fi from if you want to go down deep into the weeds of the modulation format and such, like there is a convergence between Wi-Fi and the wide area 3GPP type of standard waveforms and so on. So
did we lose Sayongita or did you lose me?
I think Sanyogita, I think somehow I got muted. Sanyogita, you're muted. Something. What happened to Sanyogita? Sanyogita, I think looks like you're muted. Are you? We cannot hear you, Sanyogita.
I guess meanwhile Sanyogita recovers her audio. I think Ashutosh, since you are
I have a question to actually one of the presentation Dorothy had given in the past, and I was going through her presentation, a lot of good information there. So one of the slide you had, Dorothy, there was the KPIs, right? And I was looking at the 802.11ax KPI, and there was a comparison between what is the minimum requirement and how 802.11ax performance matches that, right? And since the question was about the latency, I mean, I'm looking at the slide. The uplink downlink requirement for ITU was 4 millisecond, And here I see 80 microsecond. Is that correct, Dorothy?
Okay,
For
this is a very detailed question. I'm not sure that.
yeah.
So I'm happy to investigate that offline. I think you're looking at the analysis that was done to evaluate whether the 802.11ax would meet the MAC and PHI requirements as defined by
Absolutely.
IMT 2020 for two specific use cases. And those use cases or environments were the indoor hotspot and dense urban. So there was work done by Sindhu Verma and Shubhadeep Adhikari, both who are based in Bangalore and work for Broadcom, to do both the simulation and analysis work using the mechanisms, the methodologies that's defined by the ITUR, to show that in fact for those two use cases that 11ax indeed met the MAC and PHI requirements. So the focus was again on the MAC and PHI, and I'd be happy to take detailed questions offline, but I think here the main point regarding latency and some of these other QoS capabilities, et cetera, we are continuing to work these areas in the standards and in other industry bodies. For example, there's activity underway in the Wi-Fi Alliance looking at certification of additional QoS capabilities so that the QoS parameters that are expected by a cellular network can indeed be met and communicated to the radio access network when that radio access network is at 802.11 Wi-Fi network. So there's a lot of focus in that area now. And I call your attention to a very recent Wi-Fi Alliance program related to QoS capabilities that was just announced. So this is an area of ongoing work to continue to enhance the performance of Wi-Fi networks. And to follow on to Sanyogita's comment, we really do have customers with a wide variety of needs. And enterprises, they're not monolithic. They each have their requirements. Some require very, very cost-effective solutions. Some have very specific and demanding applications, whether it's in a factory or a port or whatever. And so they will evaluate the technologies that are available and make the best choice, their choices based on the technologies from an overall perspective, not just a specific technology, but the overall solution that meets their needs in a cost-effective manner. Over.
Thank you, Dorothy. Sanyogita, please go ahead if you want to add to that.
I think
just
I was
catching up on the latency, and Dorothy was giving some assessment on that latency is also going down with Wi-Fi. And
yeah, I think there's a lot of convergence in many ways, right? But at the end of the day, I think if you look at like what wide area networks get you wireless, whether it be 5G or 4G, is the seamless connectivity between indoor, outdoor, and as well as security. So I think two things, and latency is definitely something that is getting better and better. Now you would ask like how, what type of applications are we talking about? So again, it's not one size fits all. So I'm not sure. I think we want to probably look at some of the other attributes and applications perhaps. If you look at, for example, what many of our customers are talking about, let's say in a banking environment, they want to be able to have secure connectivity even for their employees' computers. So is latency important there? No. But are they looking for an alternative to Wi-Fi? Absolutely, right? So it's not just low latency applications, but applications that require maybe higher security and maybe need the flexibility of roaming or mobility and so on and so forth, would warrant a 5G network, whether it be a public 5G network or a private 5G network. I think we tend to think when we say private 5G, it's definitely indoors. It doesn't have to be an indoor 5G, private 5G network. An outdoor can be, a campus network can be a private 5G network. So I'll just leave it there. I'll let somebody else take it on.
Yeah, Dinesh, this is Subodh. Can I take a segue from
I
what
think
Sanyogita said?
voice is over. I don't know that if you want to talk about voice.
Yes, yes. So I'm just going to take a segue and bring another lens to this. I think let's level set just in the interest of the panel theme. I think we all agree about the first, I would say, 6 odd bullet points you have here. It's not a question of this or that between Wi-Fi 6 and P5G. The way I think the industry is aligning, whether it's the WBA or IEEE standards, is we all kind of agree the channel access benefits you get from OFDM and OFDMA, all that is beyond. So there's a natural advantage that both of these are built from the same foundation, Wi-Fi 6, .ax, and even Wi-Fi 6E now, when you compare with licensed or cellular P5G, which means they all have the natural capability to support new applications and use cases. I think Sanyogita rightly pointed out. And even within that, if you take the premise of SD and NFV with network slicing, Lakshmi talked about it in the intro, that's where you slice and dice. So a carpeted environment in a bank, let's say JPMC, just using an example, for high density Wi-Fi requirements with security, enterprise role-based access control is going to differ from an airport lounge or hospitality requirements, which could lean more towards security. So just giving an example. And so both of them provide high data rates, both of them give you capacity. So if you map that on the wire, so bandwidth, delay, latency, jitter, all of that. So they both can coexist, but I think the beauty is what personas are the clients changing, right? When you start at home, let's say Wi-Fi 6, when you're driving, P5G. When you're in the office, maybe Wi-Fi 6 and P5G. When you're out in the park jogging, again, 5G. When you're working remotely, again, a combo of P5G and Wi-Fi 6, right? So largely, I don't think there is a single size which fits all. I think Dorothy also covered that. There's phenomenal research, and I'm just looking at the other theme of what you shared for the goals of this panel. Just from a research perspective, especially for startups, students pursuing their doctorates or even working on their patents, largely, yes, Wi-Fi 6 will be the access choice for indoor. It is ideal, but not the only ideal now when you bring in the perspective of UR LLC for private 5G. But it's an ideal system right now. For example, when you look at stadiums or event centers, you can compare the benefits of P5G and Wi-Fi 6. So I just thought, let's also kind of graduate this discussion further ahead and bring the lens of indoor-outdoor applications, compare with how much of private 5G deployments have matured in the premise of drones or even connected cars or automated cars, and just have the next level of discussion, if that's okay for everyone. And security as well, big one.
Sure. I think. Sorry, go ahead, Ashutosh. Yeah, please go ahead.
Can I just add one more thing?
Yeah, please go ahead.
Add to what Sanyogita said, and Subodh kind of corroborated that. When you talk about latency, one thing we should not be just focusing on user plane. There is a signal plane or control plane latency. Well, if you're handing over too fast, right, that's where you have to also see how much of latency you have during the handover, right? I mean, even with 5G densification of cells, it'll look more like Wi-Fi, right, with millimeter wave at least. So you have the access point, you're doing scanning, association, authentication, all those in Wi-Fi. The same time, if you're handing over from cell to cell with different AMF, then you'd be also subjected to some kind of a latency before you even get connected. So that's something we should not forget about. Just want to highlight that.
No,
Yeah.
fantastic. That's a good point.
Uh,
We haven't heard from Victor
yeah.
and Hemant.
Yeah,
Maybe
Dinesh,
Victor
Hemant
and
here.
Hemant. Yeah,
Yeah.
go ahead, Hemant. Yeah.
A couple of points I thought I should add here. See, before deploying whether 5G or Wi-Fi 6, I think both of the technologies are coming from similar trend. So the throughput, latency, both are at par in many cases. But when you really want to deploy at a use case level, you have to understand where exactly you are deploying. If you are thinking from say mining scenario, there the power level is extremely low. You need to have very low power level. Their security may not be that high, but latency okay, and you need to have very the spectrum is also very difficult there. Like you may not be able to transmit at certain frequency due to certain conditions, certain regions. So you need to understand where exactly you are deploying. Similarly, if you are deploying, say some kind of warehouse environment where a big warehouse, then maybe Wi-Fi 6 can be better. But if you are having all kind of seamless mobility, those kind of requirement are there, then maybe this 5G, private 5G can be better. So it's not that one particular technology will rule or particular technology is needed. And both of them are needed, and both of them, as I think Rastos also mentioned, both of them can lead to some kind of solutions where some kind of profit can happen, some kind of the throughput improvement can happen. Similarly, the latency issues, specifically in Wi-Fi 6, there can be some centralized solution which can manage the access points, okay, with the all MLAI setup. Then you can predict the mobility, you can predict the requirement specifically for drones or robots kind of things, and you can do the handover in preemptive way. And if you do that, then the whatever your latency, other things can be also minimized, and packet drops, whatever we see in Wi-Fi 6 sometimes, can also come down drastically. So there is a lot of engineering solution also can be done, other than whatever Wi-Fi 6 is supporting, other than whatever 5G is also supporting.
Victor? Victor, you're muted if you're speaking. We still muted.
Okay, can you hear me now?
Yes, we can now.
All right, okay. So I'm going to take a completely different approach. I kind of want to set some context before I make my remarks. So I've been working on wireless Wi-Fi from its inception, and did actually, I don't know how many of you know, but built the first Wi-Fi hotspot network in the world. And so essentially, I spent my entire life in the past on Wi-Fi and followed all the standardization, and Microsoft, pushed it very hard, all that kind of good stuff. Now, recently, after about 24 years in Microsoft research, I had to step out and get into the sort of the product world. And the reason I got in there was because I see something that I hadn't seen in my lifetime before, which is the fact that everything is software, which means the Fi and the Mac isn't software. And we're building it, and we have built it, and we've shown it, and it works on the campus. And many companies starting to announce private 5Gs. The operators are interested. The CapEx OpEx reduction is a big deal in this case. The cloud is a big deal. The revenue generation is a big deal. Now, when you have a situation like that, this kind of a business opportunity, that the idea of throughput and latency and all actually fall backwards. They are no longer the driving forces to any technology succeeding. Now, when you talk about private 5G, think about what Wi-Fi gives you. Anything that Wi-Fi gives you, private 5G or 5G can give you, because it can operate on all the frequency bands that Wi-Fi operates on, plus all the licensed bands as well. And it is all software controlled. It gives you it has slicing, so it has like all kinds of abilities to manage different type of traffic types, IoT to phones, to data, to anything you want. And it's going to be a very well managed solution. So now if you have this solution, you've got two things competing, you are going to see one of them drop out in the end. Now, I want to say this, like in the past, I forget, in the early 2000s or whatever. I actually sat on a panel where people, when there was 3G was around, and everybody said 3G will be everywhere and Wi-Fi will not. And I was on the opposite side, and I said that's not true. Wi-Fi is going to be the one that's going to sustain, and 3G will be good for outdoors and Wi-Fi and indoors. But now, almost 20 years later, I'm actually in the side of saying that the Wi-Fi over 5-10 years is gone. It's not going to be here. So, because any sort of innovation that is happening is now being sucked into, because of the softwareization, into 5G. And as more and more momentum grows, as more and more companies get in the game, you're not going to have multiple pieces of hardware sitting on any devices. You will have one chip, and that'll be the 5G chip, which is going to be operating on all these frequencies, and you will be able to do everything that Wi-Fi does today. So that is what my opinion is. Of course, I'm not going to bet against Wi-Fi today. I mean, for the next 5-10 years, at 5 years, I think it's pretty solid. All the innovation is solid. But looking beyond that, I don't see a future for Wi-Fi. So I'll stop at that and let everybody react, because I know this is a little bit of a controversial issue, given how much
Thank you
stake all
for
of you
being
are.
that. So that
Yeah, I
inspires the
think
conversation.
many people are building their careers on Wi-Fi. So obviously this goes against that grain. So, but I'm happy to debate on this.
So
I mean, definitely, Victor. As far as the spectrum goes, there's definitely more spectrum for wide area networks versus Wi-Fi for sure. So
Yeah,
disagree on that, right? I think in the sub-6 gigahertz, where actually some things are reliable and works, right, there is only Wi-Fi, right, everywhere, right?
That's not
But
true.
Victor is correct on
Nope.
that point, that you could use private 5G
Before you go on, sorry,
Yeah.
that is not correct. The statement you made is not correct. Under sub gigahertz, you can actually have 5G, and we have it. So that's
there
I think
is
I'm not disagreeing with that, right? If you look
Oh.
at the amount of spectrum which is given to the cellular, right, and one which is bifurcated and given to the Wi-Fi. Wi-Fi has this new 1.2 gigahertz band, and maybe there are some more bands which are being released to 5G, but the overall alliance,
That's not
if you have to
correct.
set,
That's not a correct statement either. It is no band. FCC, at least in the United States, I can tell you, and I think in TRA in India, I can also. It's pretty much the same. No band is given to Wi-Fi. It is given to unlicensed devices.
I think,
hang on. And the 5G actually operates on unlicensed as well, right? About 4 years ago, Qualcomm had this thing called LTE that they were doing on 5G. And I was actually against that at the time. But as I thought more and more about it, all this unlicensed stuff is completely available to the cellular chipsets as well. So it is not given to anybody per se.
It's true and not true as well, because practically speaking, right, there is no LTE typically operates on these bands, right? And this is what going towards the practicality of these deployments, right? Very often there is a technology called multi-band FIRE, which I think Qualcomm has been promoting for a while, right?
No, but there is. Sorry, Dinesh, didn't mean to interrupt you.
No, I think good to correct me.
There is unlicensed LTE, LTEU.
Yes, exactly. I agree. I think, but it's very rarely deployed. Is my argument to that?
No, it's not rarely deployed. It is absolutely being deployed.
That's correct.
People
it's
have
not
started
rarely
deploying
deployed,
that also.
And
so
the LTE, that's exactly what I was talking about. The LTE.
Yeah, I wanted to make a point as well. I mean, I'm not commenting on the spectrum side, which obviously LTE probably has more variety there, or 5G. But Victor, I wanted to comment on your SD and NFV part. That can still be adapted to Wi-Fi networks, right? I mean, all the edge cloud, the core, all those tools can still be applied to Wi-Fi network, right?
It can, but then that's not Wi-Fi anymore. That's the point. It all converges. It converges to the same thing. Like, for example, the thing that I said, 5G is actually very well thought out. We have to give credit where credit is due. So they went and actually interviewed lots of application developers and asked them, what is it that you want? Like they asked the AR, VR guys, what latency do you want? What bandwidth do you want? They asked the cloud gaming guys what they want. And then after they had the requirements, they built the network and they actually deployed it. Wi-Fi is not built that way. Wi-Fi was built very differently. And so if you're going to see money being thrown into these applications to be building out Wi-Fi cannot sustain it, will not be able to support these, but 5G will be. And that's what I meant by 5G, 5 years and beyond. The application and the services, they will both, the Wi-Fi and both will converge into one thing. And then,
Let me
that's the point.
take this
So
on this
I,
other
I would have,
direction. Sorry,
yeah,
go ahead. Please go ahead, Sanyogita.
I would have a comment on that too.
Sorry,
So I
Dorothy.
think we have to be careful with our terms. When we say Wi-Fi, we have a certain RF component on the Mac-Fi, and at the upper layers, it's internet. It's IETF protocols, um, vanilla IETF protocols, and applications that are over the top, cloud services, etc. Whatever data networking capabilities are out there, Wi-Fi leverages. The traditional cellular and 5G architecture and network components have moved from custom designed, a very custom architecture to actually now a more generalized cloud data internet structure, that you have services now that can be provided in a carrier network that are available in cloud-based networks for other applications. So actually, I see the evolution actually the other way around. That cellular network, core network, is evolving more towards the data networking side, which is where Wi-Fi is natively. And we can argue all day long about, yes, theoretically you could have all of these services provided on a Wi-Fi Mac and Fi, or all of these services provided on a 5G Mac and Fi. It really doesn't matter. The demands, my personal view, the demands for connectivity at low cost are such that both technologies are needed. There was actually some seminal work done in the 3GPP about 5 years ago when they decided to define a 3GPP RAN agnostic interface, so that you could have non-3GPP RANs connecting to a 3GPP defined infrastructure, thus enabling WLAN, wireless LAN .11 based, or any other technology to connect into that network infrastructure. And what's going to be interesting to me is to see, okay, where does the carrier network infrastructure and core evolve to? And depending on that evolution, you can see perhaps different business players coming in. So that's the
So,
interesting question, evolution-wise.
So if I may just comment, so I agree with everything you said. The one thing I would sort of say is that, so I've been thinking about the question of why is it that these, like in the 5G and let's say 6G, whatever it is, why is it that 5G networking is more complicated than 4G? I mean, than Wi-Fi. We already know Wi-Fi works, and I know this, it's a very simple protocol. It's the CSMA. We know all this stuff from like decades of things. And then, the data stuff that you said is all true. The reason why it's complex is because of all these performance or the kinds of things it provides. And for that, you do need these components that Wi-Fi doesn't have. So you can talk about, I mean, you can sort of, I don't disagree with the fact that Wi-Fi was doing the data networking and cellular actually had its own stack and they're moving towards, but Wi-Fi hasn't kept up. That's the problem. The Wi-Fi focus has been on the Mac and the Fi and the throughput and the latency and things, but that's not what actually is driving everything. What is driving is the services and the applications. And for that, the infrastructure you need, whether you do it in Wi-Fi or you do it in cellular, you need it. And that's where the convergence starts to happen. The frequencies don't matter anymore because the radio is dexterous and can actually do, I'm sorry, not the right word, but nevertheless, you can actually use all kinds of frequencies. And then on the Mac and the Fi is in the physical layer, so you can actually pick whatever you want. So that is why I said the convergence is going to happen. You cannot
Victor,
have two chips on the same device. You won't have that.
This is a great point. Okay, let me reflect and maybe try to tease out why is Wi-Fi not to the point where you think cellular is, right? So let me make 2 points. One, Wi-Fi is extremely, extremely low cost, right? Dirt cheap. I don't think 5G or private 5G or any of these things will come anywhere close to what the cost is of deploying of Wi-Fi today. That's number one, right? And I might be wrong on this one, and you can say that I'm wrong. But before I finish, the one other point I want to make is that given that it's so cheap, right? What can we do to make Wi-Fi as capable as cellular is, right? And you seem to have a very strong belief that cellular is very well designed, right? Where is it lacking exactly? And this will help all the audiences which is listening to us to get and go to work on some of these problems, right? Go ahead, Victor.
Okay, so my reaction to your comment is the following, which is that you're looking at it from a today's perspective. The cost matter is is a question of volumes. When the volume increases, cost tends to go down, and it becomes more and more cheaper. I mean, I used to buy a Wi-Fi card for $300 to a PCMCI to plug into my Mac, and now they're less than $2. You know, they're like so cheap. Even light bulbs have it. So the volumes actually dictate all this stuff. Now, before I
again,
answer,
I can make that argument for this, right? Wi-Fi can pick up on these other metrics which 5G has, right? And will be still called cost effective, right?
right, but
It's a
no, wait,
it's a circular
you
argument
can't,
in some
no,
sense,
that,
but I would like you to comment on the parts where Wi-Fi is lacking and maybe can pick up
right,
in
but you
So,
can't,
so I
make the
think
comment. You
one thing,
can't make
Dinesh,
the comment you made and let me not. You
you
cannot.
should
What
put
you
both.
said is
You should put
wrong.
Dinesh, you have a picture on the next slide, right? We should probably put both the architecture slides side by side,
Sure.
and then it'll be easier to compare because 5G is just not new radio. 5G is end to end, right? I think
Yes.
that's what Victor is making a point there.
Yeah,
Because all the
yeah,
microservice stuff that you see in the code, obviously
and,
they have that functionality.
and yeah.
Yeah.
So
I think by the
Dinesh,
time you add all those capabilities to Wi-Fi, you think it's going to be any different in terms of pricing?
yeah, that's exactly right. So Dinesh, you can't actually say what you said by saying I can do this. You can't because it's not built that way. And then by exactly the point she made.
Yeah, I
So
agree
when we
with
do
that
it,
point. It has to be end-to-end solution, right? It's not only the last hop.
yeah,
I,
that's right.
and I
Okay.
think I think the Wi-Fi community had kind of started to converge there, right? Because if you look at the first generation of the Wi-Fi standards to where they are OFDMA, and there is more similarity in at least the physical layer between Wi-Fi and 4G, 5G and 4G are almost the same from a physical layer perspective. So they've tried to converge. It is the rest of the stuff that is not available, and by the time it's not there at this point, and by the time you add all of that, I don't know, then it is convergence, and then you're talking about a
That's
single
right.
standard, and the
Yeah,
difference is in the frequency, and that kind of dictates the scale. And then because certain frequencies are free, right, and certain frequencies cost a whole lot of money, there is all that kind of, it's hard to say that the cost of Wi-Fi is cheap because of the standard itself, or the scale. Which came first, is a chicken and an egg in this case. It's I don't know that you're going to be able to keep the cost down.
So I think I want to go to this theoretical discussion, right? On we are assembled here, and I think maybe we can bet on different things, right? And as Victor said, half of the other people were betting on 3G, and he was betting on Wi-Fi 20 years ago, right? I think the same thing we are doing right now, right? We are playing Russian roulette, right? So while I'm playing Russian roulette, I may wanna take a point here. So let me make few points, right? Wi-Fi is actually increasingly making it more look like OFDMA, where they have adopted extreme slicing and dicing, going into 11ax with having RU resource users, right? RU and so on and so forth. Concepts of very much which was popular in 11, sorry, cellular networks, right? So increasingly both of them are converging even in the way their phi max are looking like as well, right? Okay, more to the point, I think it will become some at one point Wi-Fi might go entirely a centralized control as well, right? Its own form of how cellular does, right? Okay, so now I want to still go back and ask you folks, right? So Sanyogita, you made one comment, right? That a lot of law firms are reaching out to you on having security, right? Why is an immediate answer to security use cellular, right? Why can't Wi-Fi provide that security, right? Okay, the other thing I think about Wi-Fi lacks is cellular networks are well designed, they can handle millions of nodes, right? This is something which Wi-Fi probably struggles with, and maybe I might want to take this with a caution, and Dorothy, maybe you want to comment on that, that it may not struggle, right? But I think Wi-Fi struggles with keeping up with the number of nodes, right? And so really those are the two things I can think of, right? But how can like security can be improved for Wi-Fi, right? What it doesn't do which cellular does, and how can some people work on that topic and really bring it up to the point where private 5G and 5Gs are. Sorry, go ahead, Sanyogita.
I'm not a security expert, so I'm going to let someone
Okay,
of
I
the
think
security experts speak on the behalf. I think the unlicensed part is one of the biggest challenges, and also, not a well-managed network. It's harder to manage, and I mean, enterprises is maybe okay, but still, I think there are enough issues. But I'll let somebody else speak on the security aspect.
I'll just
So,
say,
I can take a crack at it if
go for
you know. So, when I was in AT&T, I used to work for Chief Security Office, and previously at Belcore, I had done a lot of Wi-Fi related work. So, if you look at obviously the 5G security is more mature than 4G, but depending on you have this whole signaling control plane, user plane. You have security between UE, E node B or G node B, G node B to MME or AMF, then UPF. And the whole 3GPP, 23.501, 33.501 have defined all those, right? But it comes down to the same IETF protocols, IPsec, TLS, DTLS, right? Authentication, IP2, all those stuff, right? So it all depends on those IETF protocols that Dorothy talked about. And those are also used in enterprise networks. You still have TLS, you have IPsec. It depends which specific protocol you're using among which components, right? If you look at 5G network, you still use SCTP as transport and use DTLS to take care of the security between G node B and AMF. You're using IPsec between G node B and UPF, right? And so I guess the cellular network obviously adds complexity in terms of taking care of security among different nodes and how you derive the keys with EAP AKA or 5G AKA or the derivation scheme. So in my view, the security architecture is a little bit more complex in 4G, 5G compared to Wi-Fi networks, right? That's my assessment. But that doesn't mean that there is no solution. The solution is there in
Subodh.
5G or 4G network
let
as well.
me
Yeah,
let me
can I add something? Okay.
let me offer another contrarian review of this. Actually think 5G architecture security is busted at the moment, and the
Yes,
reason it's
I agree.
busted is 5G.
Good.
And the reason it's busted is it's not because of the things that were said that, end to end, we have all the higher layer protocols and then lower we sort of have it. It's because of the implementation of this. So again, you have to sort of go back to, as a sort of, this is a research conference. I took that opinion of the convergence as a way to sort of say that, if you're working 5-10 years ago, that's how you should be thinking. And so in the security domain, the way to sort of think about it is that this is a distributed system now. You've taken a hub and spoke model that existed with the hardware that did specific things and broken it up into a distributed system with many, many services running on different servers, define the MAC as separately service. And it's working on vanilla servers. That opens up an attack surface area, which is much larger than it has ever been. So, I know the cloud industry and the computing industry has actually dealt with this for a very long time in terms of trying to protect that. But the surface area is much bigger. And so one has to sort of really look into, it's not about that link itself, but it's processing elements where the attacks will happen. And those are possible unless it's really well taken care of. So I'll stop there. But
Victor, may I comment for
Yeah.
a minute? I agree with Victor. It is complex. But some of those comments you mentioned, like the additional attack surfaces, things due to SDN or NFB or slicing, orchestration, S-Cloud, those are the additional enablers that 5G provides. And obviously, it opens up additional security challenges.
yes.
But if you want to deploy the same thing in the Wi-Fi core side, I call it core means beyond the access point, right? It could be 5G core, it could be complete enterprise core. But you will be facing the similar challenges. We talk about slicing, SDN, NFB, or orchestration.
Right? I totally agree. I totally agree, and that is why it goes back to your point that it's not the same thing. So the security of that is correct. What you said is correct. if you look at all the entire surface area and all the different things it provides, then its security is weaker, but it can be performed. But Wi-Fi doesn't even have any of that. So the question of one, it's not an apple to apple comparison in that sense.
Subodh, so
Dinesh,
I want to let Subodh speak up. Yeah, go ahead, Subodh. Yeah.
Yeah, I'm finally happy somebody opened this most important thing, right? The security later approach, which is pretty much the Beth Noir. And that is, I think Victor said that right. I would agree with the busted part. What I would also like to bring in is that is perhaps the most researched and the anticipated block, right? So just to summarize, the epochal shift in the 5G architecture, which means the advantages you get with CUPS, so control user plane separation, the whole distributed ensemble, the MEC, which is the multi-access edge compute, the cloud RAM, and the network slicing, right? So the A, B, C, D. These are the architectural advantages or the paradigm shifts for 5G. However, not encompassing the device threads, the air interface threads, the RAN threads, the backhaul threads, even all the way down to your network slice security. It's not ingrained, which means if somebody builds and leverages a 5G network, a standalone or a non-standalone, to Ashutosh's point, and then thinks about, let me think about MEC security later. That's the security later approach, and that is never going to protect your house or network. I'm happy we're talking about this, and I think just in the interest of the research aspect of this conference, that is one place where if somebody wants really to nail his or her pattern, work, research paper, or even fuel their startup, start thinking about where are the air interface threats coming. For example, are you looking at man-in-the-middle attack, jamming between your rat slices? What's going to happen in a MEC with telco or those little distributed data centers, which have now moved closer 3 hops to the left? So I think it's a phenomenal place to work. If somebody here amongst the audience wants to work, these are the real challenges faced by every 5G operator, greenfield, brownfield, and that is nailing the security aspect. I'm just happy we're talking on it.
Yeah,
And
I have one point
yeah,
to add here, Subodh. See,
sure.
if you talk about 5G, 5G is actually end-to-end kind of thing, starting from your access to core to the entire part. Whereas in Wi-Fi 6, it talks only about the access part. Now, when you talk about the cyber security issues, talk about all the man-in-middle attack or even DDoS attack, when the number of users are very large, extremely large, specifically in the indoor scenario or in the enterprise scenario, there may be a possibility that the DDoS attack or man-in-the-middle attack can be there. And when you don't have the control, the entire end-to-end scenario, you don't have control, then maybe there is a scenario, there is a possibility that the threats are more in one case. Whereas when you have the entire control in your hand, then maybe threats are little low uh, in actual deployment. So definitely there are some, I think, research work should happen in that direction to understand like what exactly to be done to improve the whatever, not only the throughput or latency aspects, but the security aspects also, specifically in Wi-Fi 6 scenario, because only you have the control in the access part.
Right, Dinesh. I was just about to complete. I wanted us to separate the cause and the effect, right? Whether you say Wi-Fi 6 or private 5G or even 5G security, it's an end-to-end thing. What you described is the effect. I was focusing more on the causes, right? And the causes is because we throw open this flat end-to-end IP architecture called 5G. And we said it's completely distributed. And these are the advantages. These are the knives you use to build a 5G network. But what happens is that afterthought of security approach is what induces the problem. So the very reason for which you slice a private 5G network and give it to a bank, or mining operations, or a little transportation office in a city, you also introduce the RFID Bluetooth sniffing, right? Or the eavesdropping, which can happen on an IoT devices and messages can be intercepted. So how are you going to ensure the manufacturer usage description, for example, now that's an IETF draft, enables security for your device? How are you going to make sure malicious code injection does not happen on the drivers, right? And these are just many of the effects of the security, but I think it's a Pandora's box if you don't factor that in your day zero. In fact, I would say day -1 discussions when you build a 5G network or even a Wi-Fi 6 network. Yeah, but very valid point, Dinesh. Yes.
So, Dorothy, I wanted to hear
Yeah.
some of your opinion as well on this topic. Please go ahead. Yeah.
Yeah, very interesting discussion here among the panelists. I'd like to comment that security, as we know, is an evolving topic area, and we, over time, strive to continue to improve the security, not only of the design of our products, but at the implementation as well. And from the Wi-Fi perspective, uh, significant strides have been made over the past 20 years in the security that is available now compared to early products. So security, the fact that Wi-Fi, the claim that Wi-Fi networks are not secure is an old claim. I think that with WPA3 capabilities that are available today and certified by the Wi-Fi Alliance, a Wi-Fi network is indeed as secure, or more, at least as secure as any other network out there. The essential component of the quote man in the middle attacks is the lack of authentication and validation by the client device of the credentials of the network device. And there are protocols in WPA3 that do that validation. So networks can be built using Wi-Fi that are exceptionally secure. I think that that bridge has been passed. The point about implementation and constant need of updating of and use of IETF protocols, that's a good point. We in the .11 community have made it a point to actually use protocols developed in the IETF, because we don't want to go off and use custom protocols that then are found to have errors. And certainly that has been the case in a number of cases in the past in the cellular networks, and thus people are going to use of IETF protocols. And I'll notice that comment that EAP mechanisms, the extensible authentication protocol, authentication mechanisms have been used in enterprises in Wi-Fi networks for coming up on 20 years. Those mechanisms are now being added in carrier networks, again, to allow a variety of credentials to be used for access. Security, constant need, constant focus, and secure Wi-Fi networks can indeed be built and deployed today using certified equipment. Over.
Subodh or
Absolutely.
Ashutosh, do you gonna comment on
I,
that?
I yeah, I agree with Dorothy on that, right? And what Dorothy talked about is the last hop. In fact, if you think about the inter-RAT handover, I think initially Dorothy talked about handing over from cellular to Wi-Fi or vice versa. There is a mechanism in place to make sure if you're moving from UU to whatever the Wi-Fi, whatever SW or whatever, right? You still maintain the encryption authentication over the air. That part is still secure. And if you're depending on whether trusted or untrusted handover, right, or to Wi-Fi, you can still set up an IPsec, or you don't need to set IPsec if you're handing over to a trusted Wi-Fi, for example. So that part is taken care of. I think we are more debating on the core side, Dorothy, right? I mean, there are potential attacks on different components on the core side due to introduction of virtualization, slicing, and orchestration, all those. So that is a common factor that remains whether you use Wi-Fi or 5G, for example.
Yes, I agree. I mean, people need to deploy, and the infrastructure managers need to deploy secure networks. That's always been true, and it's even more true now with centralization in the cloud of so many applications. Cloud security end to end is critical.
Yeah. And just to corroborate, right? I've just posted in the chat. So for people looking just from an endpoint perspective, Dorothy is right on. There is an ITF approved RFC. In fact, I think it's RFC 8520, manufacturer usage description. As simple as, if I'm onboarding a light bulb, how do I ensure it downloads a profile? So from an access point, it's down and dusted. We are beyond the bridge. What Ashutosh is mentioning, Dinesh and everyone, these are I would say we don't have a full baked set of maturity approaches by the very fact that these are all, it's a nexus of 4 different things coming together, right? So we have the SDN, we have the network slices, we have the cups, we have the MEC, all coming in at the same time. So things like, how do I harden my NFVI hardware? Simple enough, maybe, to some cloud operators. How do I look at east-west security? Complex. How do I look at container security and isolation between my VNFs? Oh, goddamn complex, right? When you start looking at those. And then when you start looking at applications binding them over this VNFs or containers, superiorly complex. I'm not saying it's not being done. All I'm trying to emphasize is it has to be factored in as a day zero approach, whether it's third-party applications, securing and segmenting your network interfaces, and looking at everything from the user in the control plane, Ashutosh, which you rightly pointed out. There is no, again, a standard approach, right? Because SDN or NFV security by itself is not just about the controller or the application security. You're looking at the whole gamut from threat intelligence, forensics, analytics, identity management, defense, policies, VN life cycle. These are all pillars which need to be worked from an impact perspective, a causal perspective, and then from an implementation perspective. So extremely great discussion, just talking on the core aspect of security. Yeah.
So just Dinesh, before moving on to this other topic, I just kind of wanted to be very clear in what I was, when I say I'll take the opinion of the 5G. So yes, I think the point was made that the 5G is the holistic thing as opposed to Wi-Fi is just the Mac and the Phi. And so I was actually taking a one-to-one comparison of talking about the Mac and the Phi itself. And then everything that was being said about the core is actually correct. And yes, there's work. But even in the Mac and the Phi, the thing I was saying was that because of this movement into software, that means the Phi does the software, Phi is done by the software, and the Mac is done by the software, and it's done on regular server. That creates a security problem. So in that sense, 5G is less secure at this point than if it was back into the hardware hub and spoke like Wi-Fi is, then there would be no problem. So that's the thing that I was actually pointing to. But the other things that has been said are all accurate and right.
So more to point, right? I think there is so much disaggregation and different manufacturer of different parts and pieces of 5G. It makes it a much more complex problem to solve as well. So I'm gonna take a divergence a little bit. There is one more topic which I keep thinking about, right? Which is telemetry, right? And or manageability or management of these large scale Wi-Fi and 5G networks, right? So, and probably want to comment on where do you think each of them are, right? And then I probably think obviously the 5G is far ahead, right? That's my just guess, right? But maybe I'm wrong here, and then people can really comment on where each of them lacks, right? And how can they improve, right? Dorothy, maybe I'll pick on you and set the stage on this end for Wi-Fi at least. Go ahead.
Well, again, I think you have to be careful to compare apples to apples, right? I mean, you deploy a Wi-Fi network, that's the access, the radio access network.
Okay.
And there are many vendors, including my employer, HP Enterprise, that offer solutions to manage, and in fact, manage in the cloud, very, very large enterprise and public Wi-Fi networks. So I think that the manageability of the networks is a solved problem, and you can buy solutions for that. The you know, I don't want to talk to for the 5G case, but there you're managing. Well, to continue on the enterprise piece for Wi-Fi, so to manage the radio access network, there are platforms that do that at a very wide scale. You have cloud-based systems that do that. To do the apples to apples comparison, you have to then look at everything else that the enterprise layers on top to provide the end-to-end service. And there are the data networking management systems provide that today. So I don't see, quote, Wi-Fi networks as behind in any way there.
Victor?
Yeah, my my opinion is that there is because we are running out of time and you kind of want to open it back as a research thing, I would sort of say that the scope of research in manageability for private 5G is much more than in Wi-Fi. And the reason I say that is because we didn't talk about this at all. There is a lot of work in the ML and AI community that is, and there's a lot of money there. For example, in the United States, multiple centers have been opened with $20 million centers, and now even more money is coming with the RINGS program and things. And this is all about doing manageability with AI and ML. So that's there are lots of I talked to a lot of startups that are trying to sort of get into that space as well, because the platform now allows that. It allows you to gather the data and create the models and then be self-managing and self-regulating. Now, so don't think about the new generation as the old generation was. I mean, this is a disruptive technology, and all the ads you see about 5G being deployed, this is still only the RF side of things, but the actual manageability and things there, I think the scope to do that better and do research and create companies that do that is just awesome. And I could keep going on this, but I will stop and let others speak. But yeah, so I think, and I think Wi-Fi has done a great job. I mean, for what it is, I think it is quite well managed. And the tools are there, all the stuff is there. But 5G and 6G are open challenges.
Yeah, I agree with Victor and Dorothy, right? There is an opportunity to optimize the orchestration, the new generation OSS, as Victor said, right? The whole SDN-based approach. Things are going to look completely different. The whole element management system, having the ONAP, open manotype orchestration, closed loop automation, will make it much easier to manage, and also proactively or reactively, the causal effect, right? There is an attack happening or performance overload. How can you scale up, scale down? Those are the new additional features that 5G is going to provide. And those features can be also applied on the core side of enterprise networks too. So when we talk about the telemetry or management, we should not be just focusing on the access part, but complete end-to-end system we should be talking about.
Subodh?
Absolutely. I totally agree with Victor and Ashutosh's comment, right? So just for the audience and bringing that research area spin, right? Pivotally, which area should we work on? I think the huge paradigm shift has been the model-driven telemetry, right? So with a simple passive polling or event-based asynchronous mechanism, which was SNMP, we've gone to model-driven telemetry, end-to-end, right? So it's not just on the axis. So what was never possible, once the configuration is in place, the device happily publishes every telemetry data, who I am, what do I do on my ports, how much traffic flows, who's talking to whom, at what UDP TCP port numbers, to third-party collectors, right? So the new evolution in BSS, OSS systems, the big data capabilities, the visualization engines like Splunk, Elastic, and you can do magic with Telegraph or InfluxDB or Grafana here. And I think every vendor I know, from HP to Microsoft to even my employer Cisco, all of us have embraced this open, programmable, model-driven telemetry on the networking OS on probably every device in enterprise and networks, right? So this is a real good area, because this directly takes a use case and says, wait a minute, why do you want this data, and how do you want to visualize this data? Mind you, this question was never asked in the SNMP era. So it's a pivotal shift when you look at streaming or model-driven telemetry, and happening in both worlds. Absolutely.
We are about time. I want to maybe take 1 minute and ask everyone to comment on platforms for research on 5G or
I have
P5G.
one point to mention here. Yeah, the multipath TCP can also be a research topic specifically for this kind of Wi-Fi 6 and 5G kind of thing, specifically for telemetry kind of scenario, because people have started deploying multipath TCP, and can that improve the security as well as the latency issues? That also can be also considered.
Right.
Yeah, you can probably use SCTP if you really want to avoid multipath TCP. And that's only for the signaling part, right?
Yeah. Sorry. Good.
Yeah. I guess from a private 5G and from opportunities in terms of what 5G from a standards perspective, what we're talking about telemetry and so on. I think the big opportunity is what ORAN will enable, especially on the private 5G side. I think more so than any other 5G networks, at least initially, I would say. So while there are a lot of startups that are working in that area, Victor mentioned a few, and but I think there's still room. There's still room for some work there, innovation, research, and so on. So I would say lean in on that.
Right. Anyone want to comment on
Yeah,
the platforms? Yeah, go ahead. Sorry.
since you asked me the question about research, I still predict both are going to coexist. So the important research should be the coexistence. If you are enjoying some kind of quality of service or security and you hand over to Wi-Fi, how do you still maintain that? I mean, Dorothy is aware of that 802.11be, for example, working on this priority service, which I'm working with the DHS folks here just to see if certain first responder has a certain kind of priority service, they hand over to Wi-Fi. How do they maintain the similar priority service, right? So that is extremely important to maintain that. So optimization, handover, security, priority service, those are some important things in terms of interoperability and coexistence. That will be interesting research topic.
So I'll mention the platform thing that you've been asking. I think so. So the thing with platforms is, I mean, the one of the interesting thing with Wi-Fi had been that unlicensed and the availability of the hardware, and then we can go and do party on it. And we partied, and 20 years of research, many hundreds of dozens of conferences, hundreds of papers, thousands of papers, all that stuff happened. But the cellular stuff, it was a closed box thing for the longest period of time. So the excitement that I have personally is that with ORAN, I guess, and then it's opening up. I mean, there's a big sort of push by the operators to open up. Now, what that means is that if you're in a university, I mean, you're going to need a little bit of money and a little bit of staffing of people, but you can actually build up an end-to-end CBRS, which is 3.5 gigahertz on an unlicensed, a 5G platform network. And you don't need the operators, you don't need the telcos, you don't need anybody to do that. I mean, a lot of the software is actually available for ONF is another thing, which the Open Networking Foundation, which has been putting out a lot of open source software that you can hack it together, and then you can start to build a platform. It will require a little bit of engineering effort, no question about it, but there is nothing that prevents university students or university faculty to actually deploy this on their campuses, and the same is true for the corporations as well. And that allows us to really innovate on 5G, and it's no longer that close. So I think the platforms for Wi-Fi are already well known, and the 5G platforms are things that are going to come with all the money that are coming in the US to all the different centers. They're going to build these things, and so you will have that. And it's all about putting it together at this point. In about 2 years, you will have many people will have these platforms to play with.
Thank you, Victor. And I think to support Victor, there is also oransc.org, right? They have their open source 5G with RIC implementation available online, which you can try out, right? And that seems to work. And I think many other companies are really giving out these RIC platforms for free because they want their RIC platform to be popularized. It's a next generation battle of operating systems for 5G, right?
That's right.
And everybody's trying to fight this. So yeah, please look out and try. I think, and this is a very nice area to work in as well. I think there is a question from audience. If I have a time, I'm not sure who can inform me if I have time additionally. But
give you 7 minutes
I think,
more.
but let's wind up. I think if we can respond to the questions on the chat, that would be great. Thank you, everyone. This was really interesting session. I am really enjoyed and I learned a lot, right? And I hope our audience has gotten few problems at least to look out for, right, and work on. Thank you, everyone, for joining us. I'm gonna stop recording or stop sharing my screen and hand it back to the organizers.
Thank you.
Thank you.
Thank you, everyone.
Thank you very much.
Thank you, guys. Stay safe, stay healthy.
Stay safe,
Bye.
everyone. Thanks for hosting us,
Yeah.
guys. Thank you, Lakshmi.
Thank you. Thank you, Lakshmi, and thank you, Dinesh. Appreciate it. Thank you, the organizers.
Bye, guys.
Bye.
Bye. Thank